Hi guys, it's Saad. So it's actually a first video on the series, The First Principles. So in this first video, we'll be studying expansion of functions. So as you know that every function existing in math, from trigonometric functions to exponential functions, all of that can be expanded into particular series having coefficients and variables of x. So to expand a particular function into a series, we use Taylor series. So this series actually requires the derivatives and some coefficients to define a particular function. So let's say we have a function f of x. So according to this Taylor series, we can expand this f of x as a naught plus a1x plus a2x square plus a3x cube until infinity. So what this actually a0, a1, a2 and more specifically ak coefficient is. So this ak coefficient is defined as 1 over k factorial times the kth derivative of the function at x equals 0. So let's say this t0 function will be equal to 1 over 0 factorial times the first derivative of that function would be that function itself times f of x at x equals 0, and a1 will be 1 over 1 factorial times f's first derivative at x equals 0. So summing all of this, we can get that the first coefficient a0 is the function itself at 0, so it will be f of 0, and a1 will be f first derivative at 0, and a2 will be 1 over 2 factorial times the second derivative of the function and it's 0. So you can define this coefficient as like this. So let's say we have a function sine of x. So to find the Taylor series, Taylor expansion of this function, we actually need to figure out the cyclicity of its derivative. I mean, we won't be taking the 1000 derivative of sine of x and finding a new term out there. No, there won't be a case. Actually, these functions have their own cyclicity of repeating them over a particular times of derivatives. So let's say we have to find the first coefficient which is a0, which will be equal to f of 0, and f of 0 of sine of x is actually 0, and a1 will be f first derivative 0 will be, of course, that will, but we know that first derivative of sine of x is cos of x, and cos of 0 is actually 1, and a2 will be 1 over 2 factorial times the second derivative of the functions and it's 0. So cos of x derivative will be second derivative of sine of x, which will be minus sine x, and minus sine x of 0 will be, of course, 0 again. And for a3, this will be 1 over 3 factorial times the third derivative of the function and it's 0. So third derivative of that will be minus sine x, which will be minus cos x, and minus cos of 0 will be minus 1. But if again we will try to differentiate further, let's say here 4 will be 1 over 4 factorial, which will be the fourth derivative of the function 0, and we know that the derivative of minus cos x will be minus sin x, and minus sin x of 0 will be, of course, 0. So again, if you will try to repeat the cycle, we will again end up to this. So we can observe that after a series of 4 differentiations, this function repeats itself. So after 4 functions, we have to carry out a particular series. We won't be differentiating the function again and again. So now to expand this function sine of x, this function f of x will be written as a0, and a0 is f of 0 plus a1x, and a1 is first derivative 0 of the function times x plus f of second derivative of the function over 2 factorial times x square till infinity. So if you plug in the values of these derivatives we found out earlier, we will get that f of x equals 0 plus 1 times x plus 0 over 2 factorial times x square plus minus 1 for x cube over 3 factorial plus till infinity. So after cancelling out the terms having 0 as its coefficient, which will leave them at 0, we will get that f of x equals x minus x cube over 3 factorial plus x raised to the power 5 over 4 factorial plus till infinity. So using this Taylor series, we found out the expansion of sine of x function, and using this actually we can find any kind of functions in series, no matter it is e to the x cos of x or any kind of function existing in math. You can easily figure out this series and use it for further processes in maths. Thank you guys for watching, and subscribe channel for such amazing content. Thanks and bye.